Hey kids, welcome back to some more science. Science is cool. I have a little lesson today. It's a standalone lesson, but it's super fun because there's lots for you to do. It's no special cooking project. It's all hands-on this time. We're going to talk about electricity and specifically about simple circuits. For this lesson, you're going to learn what a circuit is, how batteries work, and then you're going to kind of put it all together and make your own simple circuit. Before we get started, I remind you, you're going to do a bunch of stuff yourself. So before we learn about what all this is, for you to do the hands-on stuff, you need to kind of gather some supplies. Here's some things you're going to need. Aluminum foil, a working flashlight. Flashlight has both the bulb and the batteries both working if it's shining, so that's a good thing to have. If you don't have a working flashlight, then some batteries, and I've got here like holiday lights that I've clipped off. So if you're going to use holiday lights, if some Christmas lights laying around, you're going to need a grown-up with a clipper of some sort to help get those wires off. That's a little more difficult. The flashlight works a little bit better. Going to need some clear tape. Going to need a paper clip. Going to need some white paper or any kind of paper. I guess it doesn't have to be white paper. One sheet should do, maybe two. And then I've got just something to draw with. You can use a pencil, markers, crayon, just one thing, doesn't matter what color. And that's what you're going to need. So let's get started. First, let's start off talking about batteries. Battery, as you probably know, is a source of power. We use batteries in electronics, like in our phones and toys. Batteries are a way to give power to things that need power. Of course, you could always just plug things into the wall. There's a lot of power there. But most of the time when we're using batteries, it's because whatever we're powering, we want to take it with us, and it's not convenient to be standing there plugged into the wall all the time. Plus, a lot of our little handheld electronics don't need as much power as a wall socket has. And this is a good time for me to tell you that wall sockets, where you plug things in your house, have a lot of electricity. Don't ever, ever, ever play with those things. They can really hurt you. We're going to use batteries because batteries are not going to hurt us. So how exactly does a battery work? A battery is a vessel, a container for electrons. What's an electron? Well, that's a little more difficult. Electron is something so tiny that you can't see it with your eyes. You have to use a special microscope. But let's think of an electron as being one piece of electricity. This golf ball can be like one electron, a piece of electricity. There's not much power here, just a tiny bit. The more electrons I have, the more electricity I have. But how do I get it to move? Well, there's some rules in nature that even electrons have to follow. Just like if I were to jump up and down, jump off my bed, I would fall to the floor. Gravity. Gravity is a rule that just is. I have a hard time explaining it. It just is. Here's another rule that just is. Electrons like to move by going from where there's a lot to where there's a little. But it needs a road to get there, something it can travel through, a conductor. What's a conductor? Well, let me give you some examples. This is wire. The wire on the outside is plastic. That's not a conductor. Electrons can't travel very well through plastic or rubber. But if I take the plastic off, inside of a wire, if you ever looked inside a wire, there's this kind of shiny stuff. It looks like the same color as a penny. That's copper. Copper is a metal, and it is a very good conductor. Electrons can travel very easily through wire. This is a popsicle stick. It's made out of wood. Wood is not a very good conductor. Nobody builds wires using wood. We can do a few experiments today in our simple circuit about what makes a good conductor and what does not. And by the way, something that's not a good conductor is called an insulator. So now that you've been introduced to electrons, conductors, and insulators, let's get started. Okay, back to our battery, our power source. The battery works because there are a whole bunch of electrons in the bottom of the battery, and there's very few electrons in the top of the battery. And the two of them have an insulator between them. The electrons can't just pop from the bottom to the top. it has to kind of go out the back door and come back around. And it really, really, really wants to do that because there's a lot down here and very few up here. It's kind of like if you're living in a crowded house and you see a not so crowded house, you want to go live where it's not so busy, right? These electrons don't like being crowded down there. They want to live up here. But they can't go straight that way because there's stuff in there that keeps that from happening, like a bunch of closed doors. It's going to have to come out the back door, the pretend back door, and go around. And the way we do that is using a wire. If I connect a wire, which I've taken the copper off, remember, electrons like to go in wire, put it at the bottom and hold it, and then put the wire at the top, now the electrons can go around to the top of the battery. But how do I know that's even happening? I can't see anything. Let's put something in there to show us it's happening. Let's make a circuit. So the word circuit sounds like circle, and that's a good way to remember it. In order for the electrons to really work, in order for power to work, you have to make sure that the electrons can always be moving from where you have a lot of them to where you have only few of them. And we're gonna make it in a circle. So I've got my battery here, and I'm gonna tape it down so it doesn't roll away on me. Okay, now like I said, when I connected this wire, I couldn't see what was happening. There was nothing to look at. But if I take a little light bulb here, I have a little Christmas light, little holiday light that I've clipped out of the string, and I've taken off the insulator on the outside. And the reason the insulator's on there is because these wires can get kind of hot sometimes when they're working, and you don't want to get like zapped or burned or something. So wires are often covered in plastic, which is an insulator. I'm going to tape my little light down because I can't do everything at once. I'm going to need my hands. Okay, there we go. And now, here, actually, let me make a circle out of this. It might be easier if you can see it as a circle. Okay. And now I have to touch my wires. They have to always be touching so the electrons can go through the copper. There, okay? I've got my wires touching. Can you see that? There it is. All right, I'm gonna bring this wire around to the back and I'm gonna tape it on there. All right. And now I've got a second wire that I'm going to connect here. All right. And can you see that? My light bulb is lighting up, okay? Because to have a circuit, I have the electrons are all rushing out of the back of the battery here, through the wire, zoop, zoop, zoop. And then it goes into the light bulb. Those electrons, when they go into the little filament on the light bulb, heats it up and it glows. Remember, things that are hot can make light. Makes it glow. And then it comes back into the battery. If I take this wire off, the circuit is open. The electrons are kind of stuck here. There's nowhere for them to go. And without them actually flowing through the light bulb will not light up. Okay, time for you to make your own simple circuit. We're going to start with our aluminum foil. I'm going to assume you don't have wire laying around. You don't actually need wire because it turns out aluminum is an amazing, amazing conductor as long as you have a nice thick piece, which is why I'm rolling it up about 6 or 8 times. There we go. I've just made some wire. Perfect, huh? You can either rip it or I find it quicker to just cut it. And I need 2 pieces. Okay, there's one. I need a second one. And in the interest of not having to cut it, I might just roll the whole thing up. Make sure it's tight. It has to be tight. If it's all floppy loose, then it won't be a very good conductor. Too many air holes. All right, I'm just gonna mash this guy together. Okay, there's my nice wire. There we go. Okay, 2 wires, okay? Now I'm going to take my writing instrument and I'm just gonna give myself a guide, something to lay the wire on. Make like an egg shaped. Can be a circle, can be an oval, doesn't matter. All right, next, remember that flashlight? That works. By working, you know the batteries are good and the light's good. Make sure it's okay with your family. We're gonna take it apart, which is fun anyway, even if you weren't doing science, okay? So There's just a little cavity in there and 2 batteries. Here's some batteries. Hey, I need batteries for power. We're going to put the batteries as our power source. We need to put them so that the part that sticks up is against the flat part. So it looks like that. Not like that. It won't work that way. It's got to be like that. Okay, it goes copper, black, copper, black, just like that. Now I'm going to tape them together. And I will tell you, the tape does not work very well. We're probably going to have to hold it with our hands too. But this should help us a little bit. Tape them together so that they are together. And I'm going to lay them on one end of my circle. And just kind of tape it down. And I'm not going to tape it in the middle because I know I'm going to have to squeeze it. I'm telling you that right now. I always have to squeeze it. Okay. Next, I'm going to add my wire. Well, my aluminum foil. I need to make sure I can touch both ends. I'm going to give it a little fold over and just put it right there. And then I'm going to kind of just tape it in one spot. Make sure you can touch the end of the battery. The same goes with your other one. Make sure you can touch the top of the battery. We have to make a circle, a circuit. So tape that down a little bit, but I have to make sure I can touch the battery. I'm going to tape that on the top to hold it on there. It's not perfect, but it should work. On both ends. Okay, so you can see that I've got my batteries taped together and the aluminum foil is taped to both ends of the battery. All right, now I'm going to wind it around here. It's kind of too long, so I'm going to give it a little fold. Now, do you see this guy? Your flashlight battery, or your lights in there. Flip it over. You can usually unscrew these. If it's an LED one, that doesn't necessarily work. You kind of, I guess I should have told you, you want the kind that is this kind of battery in it. I don't know if the LED ones, I can never try to take those apart. All right, so you can see my little bulb here has a little black part on the bottom, and then it's got a collar right underneath the light. I need to touch one end of my wire to the bottom and one to that collar. Let's see if this is gonna work. So I'm gonna set that on there, hold it, and then, of course not. There we go. So the problem is the batteries don't stay together very well. So I'm gonna hold that on the collar, and then when I squeeze my batteries, it makes the connection. The power comes out of the bottom part, the black part where all the electrons are, zips on down my wire into my bulb. The little filament inside, that's that little piece of wire inside, heats up. And if you remember from our unit on space, things that are hot glow like the sun. So the electrons go through that little wire and they can't get through fast enough, so it heats up and it glows. Then it comes out, goes back into the battery. We have made a circuit. It's kind of a hard circuit to hang on to, so I think I'd like to change it a little bit to make it easier. Let me show you how. All right, here's something that's going to make my life easier. A little battery box that I purchased online. You can probably get these in electronic stores if you can find an electronic store. And this one, the battery just pops right in. A little spring holds it nice and tight so that I don't have to be squeezing it. It does have an on-off switch on the back. Turn it on. And then it's got 2 wires coming out. I'm going to tape those into my system. In fact, I might have to fold it in there, make sure it gets a good connection. And I'll use my tape to hold it down. There we go. All right, let's see if that works. Yep, that works. Okay, so that means the power's coming out. There's a good connection here, and it goes through. This is sort of hard to hang on to, so I'm going to use something else. So I took an old Christmas light set that I had found at Goodwill, and I clipped off one of the lights, and then I used a wire stripper to get the insulator, the covering, off so I could see the wires. And now I'm going to tape those into my system. There, I've made another circuit. The power comes out of the batteries, through the wires, into my bulb, and back out and around. If I take the bulb out of there, nothing happens. But I can even change this system. I have a great big button. Chicky, chicky, chicky. Who doesn't like a great big button? Well, why do I need it? Let's say I don't want my light bulb to be on all the time. If I'm at home, I might want to go to sleep and turn the lights off, right? How do I turn the lights off in this system? I don't want to have to disconnect my lights from the ceiling every time I want to turn them off. Well, enter a switch. A switch is when you open your circuit. This is called an open circuit. There's a hole here. The electrons can't get across it. But if I close a circuit, if I put something there, actually let's back up and try Mr. Paperclip, which is also metal. The paperclip acts like a switch. It closes up that hole so that the electrons can get back through. Check it out. But I'm not going to stick a paperclip in the wall. What I can do is add a button. Let's add a nice big button. Okay. Now, when I press the button, the light goes on. What does that look like to you? Doesn't it kind of remind you of this? Recognize this? This is a light switch. These are on the wall. When the light switch is up, when it's on, it's like pushing the button. Or it's like putting the paperclip. It closes the circuit. When the light switch is up, it lets the electrons through and your lights turn on. When you turn the switch off, it's like taking that out of the system and it makes a hole inside of the box and your lights go off. That's a switch. Da-da-da, da-da-da, da-da-da. Cool. All right, which brings me to the last part of our experiment. You can now use your little circuit to do some experiments and find out what sort of things are good conductors that let the electrons through and what kind of things are insulators. We already figured out that the paperclip is a good conductor. By putting it across the gap, the electrons, I might have to hold it in place, but the electrons can get through and my switch is on. How about if I use a penny? Well, look at that. If I put a penny there, that works too. Well, that's because a penny's made out of copper, the same metal that's in my wires, isn't it? Not surprising there. How about a nickel? It looks different. Oh, the nickel works too. So I guess metals are just good, huh? How about a popsicle stick? Think a popsicle stick is going to work? It's made out of wood. Nope. Popsicle stick is an insulator. It does not let the electrons through. Nothing's flowing this way. How about a nail? It's metal. Do you think it's going to work? Yep, the nail works. So it looks like a lot of metals are going to allow those electrons through. That's good to know. What about my finger? Nope. People are not great conductors. We're mostly insulators, unless we're wet. If people are wet, then they become really good. So you can look around your house or around your school and see if you can find some things that you want to try out. Have fun with that. Okay, I have here a fun little thing that I built. It's got a few things on it we can do with electricity. It has a little motor here that I've put a spinny thing on. I put a popsicle stick because I didn't actually have a propeller. But this is a motor. I have my light bulb. And then I have a nice switch. Right now it's not doing anything because none of the wires are connected and there's no power. So let's start by giving it some power. Here's my batteries again. I'm going to tape those down. Let's start with the light bulb. Okay, you can see I've got a little circuit here. And again, when I say circle, it doesn't have to be a circle. It just needs to make sure it's all in one piece and not like broken. So it comes out of the batteries. It goes here to connect to the wire that goes into the light bulb. It comes out of this paper clip, which isn't even a wire, but it is a conductor. And then back into our battery wire again. That makes a circuit, just the light. Let's add in the motor this time. What happens when I put that in there? I'm going to take the light bulb out. Let's just connect it to the motor. What do you think's going to happen? Ready? Here we go. Ooh! That circuit makes the motor turn. All right, let's put it all together. Let's make this huge circuit. I've got my power going into my light. I'm going to try to see if I can power two things at once. I'm going to have my light. Actually, I'm going to go into the switch too. I don't always want that to be on. Let's see if we can make one great big circle here on my big circular plate. Okay. Okay. All right, let's see what we got going on here. I've got my batteries. It comes out of my batteries and it goes to the light bulb. But then it keeps going to this switch, which right now is open. It comes out of the switch and through the motor and back. So it is a circle. The reason nothing's happening is because my switch is open. Let's close the switch. Okay, well, that's kind of disappointing. My motor turns and my light bulb goes on, but the motor doesn't spin very fast and the bulb isn't very bright. What happened? Well, what happened is these two little batteries just are not enough energy to power all these things. I have to choose one or the other. Or option number 3, I can add another battery pack. So I have a second battery pack. So now I have twice as many batteries in the same system. And I've connected the batteries so the wires go from one battery to the other battery and then through the system. Now let's see what happens. Oh, look at that. Twice as many batteries was able to make enough energy to power both of those things the way they should be. So sometimes you need more than just 2 batteries, which is why some of your electronics has 2 batteries, some has 1, some has 4. It depends on what you're trying to power. Well, that's all I have this week on simple circuits. Have fun experimenting with your simple circuit. Circuits are pretty cool. And remember, science is cool.